from the heart of Dubai, where tomorrow is being built today, to the world. Welcome to the CTO Show with Mehmet. Here, we redefine technology and reimagine possibilities. With Mehmet, delve into the riveting realms of AI, cybersecurity, and digital technology. Experience the thrilling highs and lows of startups. Immerse yourself in the spirit of entrepreneurship and witness the future of business innovation being written in real time. Now, without further ado, let's tune in and explore the future.
Hello and welcome back to a new episode of the CTO Show with Mehmet. Today, I'm very pleased joining me, Ewelina Kurtys. Ewelina, she is the strategic advisor at FinalSpark, a company which is doing very interesting stuff, building next generation biocomputers. Of course, what we mean by this, we're going to discuss all this. But before to deep dive into the topic, as I do always with all my guests, Evelina, tell us a little bit more about you, your background, your journey, and what brought you to where you are today. So the floor is yours.
So I'm Ewelina Kurtys. I come from Poland, and I lived in few countries in Europe. Now I live in the UK. I'm neuroscientist by background, but after some time I left academia and I started to work with startups or on artificial intelligence. And currently I work with FinalSpark as strategic advisor. And FinalSpark is building new type of computers, living computers from living neurons.
Great. And thank you again, Evelina, to be with me here today. Even when you reached out to me and I started to read about the company and what you're trying to do, the first thing that came to my mind, and I think, of course, like I come from technical background, I can understand these things. But for most people, maybe when they hear computers made of living neurons, so their mind will go like, this is science fiction. Like, what is that? So what is you think is the common misunderstanding about what you're currently doing, and how do you define this space, Evelina?
We are trying to build computers from living neurons. I think it's quite simple topic, to understand on the high level. We are using neurons the same as we have in our brains, and we know that these neurons are very efficient in processing information. They are 1 million times more efficient than digital computers, which we have today. So we want to solve this problem of AI scalability. We want to be able to provide artificial intelligence, which will be more accessible because it will have lower price due to less energy consumption.
Great. So FinalSpark, originally the company didn't start, as you mentioned, like as a biology first company, but like as hardcore AI and math driven, you try to do this. So at what point the team realized that it should not be only software, but also biology?
We realized this when FinalSpark was founded. It was founded with a dream to build thinking machine. So FinalSpark did some fundamental research in digital artificial intelligence for a few years. And then the founders realized that it's too expensive to do this. And if you are a small startup, you want to make a difference in AI, you have to be more innovative. You have to figure out something new, something different. So they decided to try living neurons because they are the most efficient known unit for processing information. So this is how it started.
Evan, can I say, the company is at the intersection of AI, hardware, and biology, or you would define it as something different?
No, I fully agree with you.
It's an intersection of these three, right?
Yes.
Cool. Now I'm gonna ask you a question, and again, I don't claim myself to be the scientist by any mean, but I like science. I like to read also about history of things, and also sometimes, coming, as they call it, in English, the rationale of doing things. So when we think, because you mentioned the word cheaper multiple times, right?
Mhm.
um and of course efficiency. Now when we think about the traditional way, and just for the people who are not that tech savvy or they
Mhm.
don't know how chips work, so just I'm explaining, and then I'm gonna ask you, Evelina. So chips are made from silicon, which is like the material which exists in our world, and this is why they call it the Silicon Valley. Anyway, so the silicon chips keep getting faster, right?
Mhm.
um and every time we see like a new chip that is getting like more transistors inside, they're able to fit more power into it. In your From your perspective, let me ask you this way: why you think still there is actually a better way of doing this, especially now in the age of AI, where we need the more efficiency, we need, like, especially from power perspective and compute perspective. We know that all these large language models, they are like CPU hungry, as we call them, or compute hungry. So to simplify it, why you think what you do is better than keeping with what we have been doing for like more than 60 years, I would say now, rush just relying on silicon.
Well, as mentioned, living neurons are 1 million times more energy efficient than silicon. So we want to be able to provide artificial intelligence, which will be much more affordable. It will be much cheaper. And today, maybe you don't feel it, how AI is expensive, because, for example, OpenAI is losing money. So that means the price of large language models like ChatGPT are lower than they should be in reality to cover the cost. Currently, OpenAI lost $19 billion dollars. So, of course, this is because this is a phase of adoption, but we can expect that in the future this price will go up. So AI is actually quite expensive, and when we use it more and more, this problem of price can be more and more painful. So that's why we think that using more energy efficient hardware will solve this problem.
Great. Now let me ask you a little bit kind of a technical question,
Mhm.
Evelina, for you now. When you say programming neurons,
Mhm.
right? So what do we mean? Like, of course, when we think about writing code, right, we think about maybe training a system. So in that context, like, what exactly we mean by programming neurons? How does it work?
So neurons they process information through spikes and generally through chemical and electrical signals. And that means that in the lab you can put them on electrodes and you can send them electrical signals and you can also measure the response in form of electrical signals. So currently we put neurons like that. You can see this live on our website, finalspark.com. There is section live. So you can see this in reality, how it looks. And what you can do is you send electrical signals. So this is like an input, and you also measure the output, the answer from neurons. So that's basically the programming, kind of the beginning of programming, because you send them some signals, you measure the response, and you want that there is logic relationship between this input and output.
Right. Also, when I checked the website, Evelina, I found
Mhm.
out that FinalSpark, what you call it, the neuro platform, is
Mhm.
described as a first remote access biocomputing lab in the world. So, does it mean that any scientist or anyone, of course, you're gonna grant them access, but I mean, how easy is it to access um, the platform?
Yeah, it's very easy. You can access this via internet browser. So actually, it doesn't matter. You can, if you do research in our lab, it doesn't matter if you are sitting in Switzerland in our lab or anywhere in the world, because every experiment we do is basically writing code in Python, programming language, and everything is executed automatically. So that means that people from anywhere can do this.
That's great. Now, in addition to this, and again, maybe now the audience will not like what I'm doing, but I'm curious because also I read the document that you shared with me before, and
Mhm.
I figured out that it's not only about the electrical signals that you just mentioned to us, but also like there are like some chemical signals. Like I mean, I'm and excuse me if I'm using wrong terms. Correct me if I'm wrong, Evelina. So
Mhm.
you're using like injecting or interacting using dopamine and serotonin and other chemical stimulations. Um, what's the reason for that? Like, is it again to be more efficient? Is it like to help in the training? What's that exactly used for?
Yes, as mentioned before, neurons are processing information via chemical and electrical signals. So yes, we also do use chemical signals in this case dopamine most often, as you mentioned. And why we do this to reinforce the learning? Yes, because dopamine is believed to take part in learning and reinforcing seeing the connections between neurons. So reinforcing the behavior.
Evelina, quick question:
Mhm.
these neurons, how do you sort them? What they are?
What do you mean?
Like, because if I think again in the traditional way, to have a processor, a microprocessor, I need to source some silicon. I mean, from manufacturing perspective, I'm just thinking out loud. So, like, where do we get these neurons from?
Okay, then we get them from stem cells. You can buy commercially stem cells, which are derived from human skin. So basically,
Okay.
are transformed into stem cells, and from the stem cells, you can theoretically get any cells you want, including neurons.
How much is the lifespan of these? Like, for how long they can stay?
Usually, well, depends. They can live for months, many, many months, but on the electrodes, they can usually live around 3 months only. Because it's not a natural environment, and we still have to find solution how to make them live longer on the electrodes. And we had some success of 7 months, but this was really outlier. Usually, it's around 3 months.
And again, excuse my ignorance, Evelina, because really I'm getting more curious about this. So you have the stem cells, their lifespan, let's say it's between 1 to 3 months on average.
Neurons. I talk
Neu-
about lifespan or neurons. Yes. Mhm.
on yours, yeah. Again, you need to correct me a lot. I'm not, that savvy on this. So when how so do you take this, do you store it somewhere until you get the new neurons there, like meanwhile, or is it like a kind of a continuation, so you always have the reserve of living neurons that would keep the system alive? I'm just trying to understand how you keep the lights on,
Yes.
knowing if you can explain that to us.
Yes, you can freeze the cells so that you stop any activity from them, but you can always bring them back to life. And you can also just keep them in medium alive at 37 degrees, and you can keep them for a very long time like that.
How do you see the use in for the mass? I mean, to commercialize this project, Evelina. Do you see that as a replacement for GPUs, or like more like a replacement for coprocessors? Any specific areas? You talked about AI, you talked about the LLMs, and how big companies like OpenAI and others, they're losing money because, again, what they're doing is, we are repeating this. But if I want to take what you're trying to do and put it into a little bit kind of a commercialization perspective and real life usages, where do you see this, or if you have already that implemented somewhere?
So no, it doesn't work yet. It's still in the stage of preparation.
Hmm.
We are working on prototypes, and what we want to do is to replace the processor, silicon processor, with living neurons processor. So basically, you will have computer where instead of silicon you have living neurons, and we believe that the best application for that will be generative AI. Because of the nature of this processing, we believe that neurons will be doing this much more efficient, and then when they will be much more suitable for this kind of tasks.
Let me ask you kind of a science fiction thing here, Evelina. And
Mhm.
this question that just came to my mind, I didn't prepare it really. um do you see this kind of also what call it portable technology? Because now when we think about AI, and of course my audience would know, they heard it everywhere or read about it, that companies are rushing to build data centers, and they are building like massive data centers to cater all the need. So if I think about what you're doing, and the micro scale or even nano scale of the neurons and how small they are, can I think that maybe one day I would have all the capacity, computing capacity of a data center, maybe in more small form factor, that actually I can port it with me anywhere in the world? Or this is too much science fiction for now and that doesn't apply to what you're doing?
No, I think that I'm not. No, I don't think that processor of living neurons will be smaller. It's not here about the size. It's more about energy efficiency. And I personally don't believe in portable equipment at this stage because neurons, they need very specific conditions. So we believe more in central bioserver, some central computer where you will be able to connect like today to the cloud, and that this will be the solution, that you will have this remote access.
The reason I ask you, Evelina, because now, when we talk about power here, we don't talk only about the energy efficiency of the chip itself, or the components inside the computers, but also everything around. So data centers generate a lot of heat,
Mhm,
because there's an emission out there. And even we started to see some of the
mhm.
known figures, like talking about, like, yeah, let's put the data centers in space, um like with that, if once we have the proof of concepts for this, would make this idea obsolete, because at that time we don't need to have actually to think about building data centers actually in the cloud, quote unquote, in the space, and as- and will defy all these theories that they are saying, yeah, if we need the best, we don't need to have the global warming effects of the data center, so let's put them in space. When it comes to living neurons, can this be kind of a good alternative from a climate preservation perspective, do you think?
Yes, of course. If they use 1 million times less energy, then obviously they will be producing less CO2. Yes, you're right.
Yeah, so again, I'm asking, maybe to you it would be silly questions, but
Mhm.
do these stem cells, like, can they also be put in space? I don't think there will be a need in that case to put things in space, and you can have the neurons here on
Mhm.
next to us anywhere, right?
I think it doesn't make sense to compare this. The problems with the silicon is totally different than
Yes.
you have with living neurons, so it doesn't make sense just to compare this.
Right. Now, you gave free access to selected universities worldwide,
Mhm.
uh, and this is part of kind of first sharing the technology, getting, I'm sure, like, it's getting feedback. um but from strategy perspective, why was open innovation more important than like locking everything behind intellectual property like IP? And I know that at the same time, like, we have selected like not many, like out of dozens university, only handful were selected. So why did you take this approach, and you didn't kind of put a paywall behind what you're doing?
What do you mean? Why paywall? What do you mean?
So you kept it like an open university, so you gave free access to universities, like
Yes.
you didn't charge them. Like, was there a reason for this? And anything that might affect the intellectual property, the IP, moving forward, because you've shared the technology with other universities?
Well, our technology is protected with patents, so
Mm-hmm.
that's another story. And we gave access to few universities. That's more was like early adopters. We wanted to see if people are interested and what they could do with this. And the objective was to give them access at the condition that they can publish some scientific paper. So that was our interest, that they publish a paper and show to the world what can be done, because we focus more on patents, not so much on papers.
Mm-hmm.
So so that was the rationale. But now we have a lot of actually users who pay us to get the access, and we saw that our lab is getting interest.
Ewelina, did you face, as company, of course, any concerns from people talking about, yeah, hey, like this is living neurons, and we have some ethical concerns about it because like you're taking, you're getting the stem cells and all these things. So were there any red lines, especially when I talk to people in biocomputing? They tell me sometimes of course ethical and also some regulations. So if you can just explain this to the audience from your point of view also as well.
Yes, people ask us question. Uh, Sometimes, for example, how we get the living neurons, or why we use them. Of course, it creates a lot of questions, and it's normal thing. So that's why we also do communication a lot. We try to talk to press, to podcasters, to familiarize people with this topic, so that they don't have to be afraid of this, because we usually are afraid of things which are not known and not understood by us.
Got you.
Mhm.
Now, there will be always, Evelina, some people who we call them the skeptics, right? So who always
Mhm.
like to doubt. Um, and they will argue that anything related to biological computers, it's gonna stay in the labs. If we want to counter argue these folks,
Mhm.
you know, what you would tell them?
I think it's okay that not everyone has to like what we do,
Sure.
and I don't try to convince anyone about anything. We just like to answer questions and spread the message about the science. But if someone doesn't is not convinced, that's fine.
Do you think there will be a moment where when this succeeds, right? And you
Mhm.
have like early signs that um there is a way for this to
Mhm.
succeed at that time, and maybe it's kind of a philosophical questions as well.
Mhm.
When all this succeeds, right?
Mhm.
um and we talk about like different use cases, and you mentioned AI, right? But at that time, I don't know what's the time frame. Maybe you can tell us. But by that time, do we have to actually redefine the whole AI thing? Because when I think now about it, we're talking about neurons, right? We talk about something biological. It's not
Mhm.
artificial anymore. Do we have to redefine? Maybe it's a little bit philosophical question. Um, am I right about the way I'm thinking? Because it's not artificial anymore. It's like
Mhm.
biointelligence. I don't know what should you call it by that time.
I think that this is question for philosophers that I would have to decide. We are just scientists and engineers, so we actually reach out to many philosophers to encourage them to work on this topic, and we hope that they help us to answer this kind of philosophical questions. So I really don't know.
Okay, that's fine. Completely understood.
Mhm.
Now, if we try to compare, I know it's completely different things, but the attempts
Mhm.
of putting chips within humans, we know like what Neuralink of the company
Yes.
headed by Elon Musk is trying to do. If I want to take what you're trying to do, and can we also imagine that we can transplant, quote unquote, again,
Mhm.
intelligence within the human body? Is this a use case which is possible in the future in your from scientific point of view, of course?
Yes, definitely. I think it will be possible in the future to input some knowledge into the human brain, and our work will for sure contribute to this, although it's not our objective. But if we learn how to program neurons in vitro, we might be able also to affect human neurons in the brain. This will not be done by FinalSpark, but I'm sure others can take this knowledge and use it.
So there's a lot of branches I can see, Evelina, from
Mhm.
scientific perspective that they can
Yes.
branch out from what you're trying to do. So, and I can imagine kind of hybrid maybe architectures also as well between the traditional compute and biocompute at the same time, which is as we started, it looks like um, science fiction, but it's not because actually you have the prototype for it. You mentioned that you're still in the early phases, so um, I know like no one can definitely, especially when you're doing all these scientific research, you cannot get the definitive answer. But are we talking here, if this succeeds, when we could expect it to be mainstream? Like, is it like 5 years, 10 years? Of course, you don't need to give me a specific answer. I know it depends. But in your mind, as strategic advisor, like if you want to put a deadline, like by this date, like this is either we prove it works or it becomes mainstream. Is there like kind of time frame in your mind, Evelina, or maybe for the company?
Yes, we do have a timeline. We assume that we will be ready with the computer in 10 years. That's
10
our
years. Okay.
yes.
Okay. So
That will
yeah, but
also, maybe I
yeah,
mentioned
please.
also, that will a big part depend also on the investments, because currently we are self-funded by the founders, but we are also talking to external investors seeking 50 million Swiss francs external investment, and with this money we can accelerate our research. So that's
I
very
get it.
important for us. Yes.
Great. Now, I gotta ask you also a question, Evelina. For you personally, right, on a personal level, when you think about this project, um, of course, other than the scientific aspect of it, does it make you feel like more responsible? Does it make you feel like some discomfort because if something goes wrong with this or like as a scientist and engineer, it's just we
Mhm.
need to test and then see the results, and based on it um we decide how to move forward. So personally, how do you feel about this project?
Well, I feel that this is fascinating science, really exciting. We are a very small team, and I think it's nice, really nice piece of work we are doing.
Great. What do you tell people who are like studying now in the university, or maybe they are like just fresh scientists or engineers listening to us today, and you want to draw their attention to work in this field in biocomputing? So what do you share with them?
I think if someone is interested in biocomputing, a good idea is to check our website. We have a lot of resources on many different levels, and it's also good to check our paper in Frontiers, only one we published, and that's a good introduction on which kind of science do you need to work on biocomputing.
That's great. Final, as we're almost coming to the end, Evelina, if you want to, tell us where people can get in touch and whether they are just curious or maybe they want to get access to what you do, where they can find more information and get in touch.
Yes, I think our website is the best. You can also send us direct message from the website, and we answer
Hmm.
every email. So
Great.
finalspark.com is the go to place. Mhm.
It's the go-to place. Great. Well, that was great, Evelina. Thank you very
Thank
much
you.
for sharing, your insights today. I'm gonna put the website in the show notes so people who are listening or watching us, they can reach out and get in touch. I really appreciate. It's a really interesting topic,
Thank you so much.
and it's the first time we discuss biocomputing on the show, and I'm happy that. I'm hoping that I'm the first one, even here in the region, that we are talking about this very advanced technology,
Mhm,
which is looks like science fiction, but from
mhm.
what I've checked also already, like there are like promising results. And this is for the audience. This is how I end my episodes. If you just discovered this podcast, thank you for passing by. If you enjoyed,
Thank
give me, a thumb up and share it with your friends and colleagues. And if you are one of the people who keeps coming again and again, thank you for following us. Thank you for your
you.
support. I really appreciate all what you do to the show. And as I say always, stay tuned for a new episode very soon. Thank you. Bye bye.
Thank you.
Hit that subscribe button. Share the show with your tech-savvy friends and fellow entrepreneurs, and leave us a review on your favorite podcast app. Your support means the world to us.